Now, let us try to look at the some kind of rapid assessment. So, we'll be talking about the revision for 5-10 minutes, and then five types of Z will be looking after. So, can anyone tell me about the name of the city in which you are staying? Name of city in which you are staying. Please write down name of city. Anyone? Can you write down in the chat name of your city? No one? Um, Bangalore. Okay, we'll talk about the Bangalore. Right? We'll talk first Bangalore and then the Mumbai. So now let us think that in Bangalore we want to find out uh, the simplest thing to find out is the water supply in Bangalore. How many people are adequately supplied water? That is the question. In other sense, water coverage, adequate water coverage in Bangalore city. And we want to have only 19 individual, and based on that we want to find out whether there is a the 50% coverage is there or not, 75% coverage is there or not. That we want to talk based on 19 individual in the Bangalore. So let me quickly tell the answer. Is it possible that based on 19 individuals we can find out the whether the coverage is 50% or coverage is 75% or not? Can we do that? Yes or no? Answer is yes. For example, we'll quickly go through it only in 5-10 minutes. Quick revision that any city or any district you divide into the various subunits, right? Geographical subunits. So, and let's see whether it's possible or not, right? Mhm. So we have seen the lots quality assessment sampling technique. Now, this you should look into the matter from the Bangalore city. Let's say this is data of a Bangalore city. And we say that for timing, understand that this file will be given to you so you can utilize this file. You should not try to use the original file. Make a copy and then use it. Let's say that you have this data with you. This is the data of various wards in the Bangalore along with their population. This you can have. If there is any problem, please let me know. This is what you have, the ward of the Bangalore, and then you put it into the original file and that you have kept replaced. And the additional data, except the Bangalore, you remove that additional data. So now the Bangalore city data is now available with you. And then you need to write down that only with 19 individual, you would like to find out whether the coverage is there adequate, the 50%, 75%. We will not say the coverage is 50% or 70. We will say that coverage is not more than 50%, coverage is not more than 75%. That the language which we are going to use it. So first step, if you have any problem, let me know. So you have, let's say, data of the Bangalore subunits, that is the various wards, and you have the population of that wards, and you copy and pasted in this, right? Instead of 19, you can keep, let's say, 30 also possible. Then you will have more sample over here. So the first thing, you write 19 over here. If you want to have more precision, you can have 25, 30 like that. But 19 would also give you the very good the resolution or very good solution. So what it is doing, that the first village, or in case of Bangalore, first ward, this is a population, it will give you cumulative population in this column. Cumulative population is given over here. Based on the cumulative population, it will automatically find out the sample interval by dividing total population divided by the number of sample size. Here is the formula, right? So if you change over here, if you let's say write a 30, sample size will automatically reduce over here. If you do the sample size 10, then sampling interval will naturally increase. So keep it 90, and then automatically from which word you need to take a sample is coming like this. This is first, second, third. Similarly, you will have the sample size. In this case, population was too much, and that's why there are 3% to be taken from this. So totally it will be 19. Suppose if you do the population over here, let's say you keep it over here, 99,200. Automatically you get more sample from here, right? So this is a file which you should be able to use it for lot sampling, actually doing it. So first thing, you copy and paste your words and population over here. Clear? Second thing, you decide the sample size. Third thing, then you try to find out from which booth or from which word you are supposed to take the sample. So these are the things from where you are going to have a sample. Now the point is how to select one individual out of 2000 population. This one individual out of 1308. For this purpose, you have various methods. Either you go something like cluster sampling technique, geographically random location from the center, and then the 360-degree random number, find out the root, and then also center to the periphery, find out the random number, and then pinpoint a spot. Or if you have a family listing, you can select a random family number from simple random table, and then you select one family out of that 4%. Again, you select one person randomly, and then ask whether there is adequate water supply or not. Suppose you have asked such 19 individuals only whether there was adequate water supply or not. Now, what is the interpretation? Out of 19 individuals, how many have said yes, there was adequate water supply? How many of them have said that? You need to find out the answer. Out of 19, 7 may say, 8 may say, 9 may say, yes, we had a water supply like this. So this you will find out. Now, if you have cleared up to this, then the next stage is very, very simple. Any questions so far? So the next thing is we go to the LQS decision rule table. So most frequently people are taking is 19, figure of 19. Right? So what you are supposed to say that how many are having adequate water supply? It's out of 19, 7% says that we have adequate water supply and 12 says that we do not have adequate water supply. What does it mean? That if only 7 are having adequate water supply, it says that more than 50%, more than 50% are not having adequate water supply. I repeat, if only 7 says that I had a adequate water supply, that means 12 had no adequate water supply. That means 50% or more people are not having adequate water supply. This is what it means. And out of 19, if out of 19, if 12 says that we have adequate water supply and 7 are not having adequate water supply, so the answer is 75%, more than 75% coverage, if they say, is not there. 75% or more coverage is not there. Here, 50% or more coverage was not there. Here, 75% or more coverage was not there. So, what is the logic behind? Out of 19, 7 had water supply. That means 12 had no water supply. That means 50% or more had no water supply. So this is a something which says that this is not existing. If 12 are having water supply, 7 are not having water supply, means 70% or more people had no water supply, adequate water supply. This is how it gives the thing. So it says that this much coverage is not possible. And what is alpha and beta over here? In this case, yellow area and this blue area, more than 10%, more 15%, right? But in this white area, when we say the white area, our confidence is 95%. That is the beauty of this uh, loss quality assessment sampling technique. So the in a summary is that it will not tell you what is the coverage. It will only tell you that this much coverage could not be there. Because you see, out of 19.7 is much less than 50%. So 12% are not, 12 individuals are not, that means more than 50% are not covered. So it will say that 50% or more people are not covered. This is what it says. If 12 are adequate water supply and 7 are not having water supply, then it will say that 75% or more coverage is not possible. So it is somewhere over here, less than 70 or less than that. So this is how in a bigger city, if you want to find out the patient satisfaction level or service satisfaction or vaccination coverage level or any utilization of a particular type of foods, or even you want to talk about the addiction, whatever you want to find out in terms of coverage, that this much coverage is not there. This is the simplest technique, and within you can say that 2 to 3 days or at the most 5 days you can cover the whole city, provided you have to have the sampling frame, not it individuals, but at least in terms of the bigger dimensions, at least the wards, etc. Any question? So practically, if not the whole city, at least in the small wards or in the hospital or in the classrooms, 10 classes, you should try to utilize this. Would be one of the assignment. This also we have seen, and you should, in 2 minutes, we'll see this, that you should try to do this figure, kappa test. This you should have taken analysis from AP info. From how you can get the AP info, the data. Previously, saw that you want to do analysis on Excel data. I hope by now most of you have installed the AP info. So in AP info, you select XLS, and you down save the Excel version one step down or previous version. That will be better. So I'm using the older version of XLS, not the latest version. So it will be better to analyze the data. And then you can select the file like this. You can see the record like this. So another file which we usually use is Oswego. In that, you go for the projects. In that, sample database, sample project. I'm just talking you how to go for 2 by 2 table. It will take some time. So now 2 by tables command will give you 2 by 2 tables. Right? The chocolate. For timing, consider this is 2 by 2 table like this. And this figure 245, 126. These four figures, 1, 2, 3, 4, if two teachers are there, that you are supposed to enter over here. So here you will add a figure. Say both the teacher agree in 10 cases, disagree in 9 cases, both disagree, yes, no, is around again a 15, and both disagreement only 10. If you look at the data like this, is the almost the negative things, right? If you keep it 20 over here, it is 0.09. If you give 30 over here, then it is 0.34. Both yes and both no is an agreement. Yes and no are disagreement. So it based on that, it says that how much is the agreement between two assessors. One clinician over here, other clinician over here. So that, or one judge over here, second judge over here. Or your one method over, second method over here. So agreement between these two is seen over here. Suppose if you keep it over here like 50, 50 over here, and 1 and 1 over here. Then you can say that agreement is 0.96. Almost both are agreeing. This is a kappa score which you can find out. Any question? Else we will be going for the which kind of statistical test we applied when. Now, this is something if you have by chance note and pen, you should prepare your own examples, own formulations if it is possible. And I think there are 5 types of Z, and each of you at least let me name who should write what, so that you need to present that, whether you can prepare or not. The first thing, Rishikesh, you will be preparing an example in which we are comparing individual with the population in terms of the mean. So here you will be using standard of mean. Then the next person, Dupashri, will be using standard error of proportion. Then the next, Bala Subramaniam, you will be talking about standard error of difference between two mean. Then next, uh, Dr. Soumya will be talking about standard of difference between two proportion, and the Dr. Surbi standard error of between two mean. Now, let us talk first about this. This is a very clean slate in which you have 100 individuals are staying in a hostel, and their mean weight was 50 kg, and the standard deviation was 5 kg. Now the question is we start with a very simple thing in which there is a person who is having weight 75 kg, 30 kg, 57 kg. Now the question is whether this 75 kg person is likely to belong to this group of 100 or not. So we are trying from simple to complex. So answer is this is 50 kg, this is 75 kg. So if you do plus minus 2 standard deviation, this is a standard deviation, this is a mean, and this is n. Now the 95% people will lie between 50 plus minus 2 into standard deviation. So 95% will be covered over here. That means between 40 to 60, 95% will come. So when a question is asked to you 75 kg, 30 kg, they don't belong to usually this group, while 57 kg person is likely to be within this group. So how do you write in formula would be Z is equal to, this is the first Z which we are using to compare individual with a population. This is the first Z which we are using to compare individual with a population. And the formula will be like this. Z is equal to mean minus observation divided by standard deviation. So it says that how many standard deviation away. So in this case, you can see that 50 minus 75, you will be taking in an absolute value. So 25 divided by 5 equal to 5. Is equal to 5. So Z is more than 2. So it goes beyond the standard normal curve, the limit 95% limit goes beyond that because two standard deviation away. So possibility that this belongs to the group is less than 5%. So when Z is more than 2, we say that probability of this person belonging to the group is less than 5%. And if you take this 57, then 50 minus 57 will be 7 divided by 5. 7 divided by 5. So the answer will be 1.4. So Z is less than 2. So the probability that it belongs to the group is more than 5%. So we say that we accept the hypothesis, null hypothesis, there is no significant difference if a person is having 57 kg weight. So here you use one kind of Z. Now, there is other possibility. See, let's see that. Then you are comparing sample with a population. You are comparing sample with the population. When you compare sample with the population, so there are two things which you can do. Whether the sample is representative of the population or not, that you are finding out. Or other thing which you find out, based on a sample, you can find out what is the proportion in population. So standard error of proportion, there are two uses. I repeat, standard error of proportion, there are two uses. Based on a sample, you find out the population parameter, or if population parameter is given, you can find out whether the sample is representative or not. Similarly, in standard error of mean also you find out, based on sample you find out the population mean, or if population mean is given, you can find out whether the sample is representative or not. So there are two uses of standard of proportion, two uses of standard of mean. Now, in this case, let's see standard of proportion. In this Z, the formula is population proportion minus sample proportion. And other way around, if a sample proportion plus minus 2 standard error, it belongs to this, then sample is representative. Suppose Ahmedabad is having a 60 lakh population. Out of you are taking a sample of 200 and 150 people are happy. So you want to find out that how many people are happy, that you want to find out. So in this case, the sample proportion is 75%, right? So this, let's find out the PQ upon N. So here we find out PQ is square root of PQ, T is 75% multiplied by 25%, not 25%. So that will be the divided by 200. That will give you the approximate idea, and then you take a square of it, then you will get the standard error of proportion. So let us do that calculation. So something like 9.3 and take a root of it. So it will be almost 3. It will be standard error proportion is 3. Now, what does this mean? Standard error proportion, it means that standard error and standard deviation. Do you think that standard is one kind of standard deviation? Then we'll move further. My question is, before I apply the standard over here, the question is, do you think that standard error is one type of standard deviation? Answer is yes or no. This is a very important question, and if you can answer this, 50% mark you will have. Do you think that standard error is one type of standard deviation? Even if you take half an hour to answer this question, is worth understanding this because standard word comes so often, many times. That's why this is to be answered. Anyone? Otherwise, how do we do plus minus to standard error, plus minus to standard difference into mean like that? Anyone? Yes, no, or do not know. Write something over here. Yes, no, or do not know. At least some of you should write down. Yes. And anyone else? Anyone else? So the thing over here, we need to understand that this standard, when we say standard error, right? So be attentive over here. When we say that standard error of proportion, what does it mean? It means that if you have a population of, let's say, 1 lakh population, you have, let's say, 1 lakh population, and out of that, out of 1 lakh population, you want to have sample size of 1,000. How many such sample you can take? How many such sample you can take out of 1 lakh population? You want to have a sample of 1,000. Any answer? I would like to continue till 12 midnight today, till you answer. Everybody should get involved. How many samples you can take? 1 lakh population, each sample in 1,000. How many such sample you can take? 100? Anyone else? Anyone else? I don't know. 100? Yes, at least two answers are there. So the answer is it will not be 100, 200 like this because you just replace one with other, the sample changes. So you can have, there is a special formula for that, but at least you will have thousands of samples, not 100. And now remember that on x-axis you take a proportion shown by a particular the sample, and on y-axis you are saying number of samples showing a particular proportion. I repeat, on x-axis you are taking the proportion in a samples, and on y-axis you are taking number of samples showing a particular proportion. So you will have inverted U shape curve, and this mean of the proportion of the sample, when you compare with the standard normal distribution curve, you will have answer that the standard error of proportion. So what is the thing is mean of the proportion of the sample plus minus 2 standard deviation of the proportion of the sample will cover 95% of the samples. And these standard deviations of this, the proportions around the mean is we are labeling as a standard error of proportion. So standard error of proportion is nothing but one kind of standard deviation, a specialized standard deviation. Similarly, standard of mean is also one kind of standard deviation. Standard of difference between two proportion, standard error of difference between two mean, all these are nothing but one kind of standard deviations. But these standard deviations are found out by a special formula so that you need not go and calculate so many samples. So then it becomes very simple that in this case, because standard is 3, so what the now, if you want to find out that what will the how many people will be happy in Ahmedabad, then you say that population proportion belongs to what is the sample proportion? Is 75% plus minus 2 into standard error. That means 6. 2 into 3, that's 6. So you can say that in Ahmedabad, 69, 69 to 81% of the people, 81% of the people will be happy, provided you have taken this sample of 200 by a random sampling technique. Now, this was the data submitted by you to the commissioner. But when commissioner did a survey of the whole population almost, the data was 46% were happy. 46% were happy. So what do you think about this? So answer is that your if the 46% is the population proportion of happy people, your sample says is 69 to 81%, but in your says it was 75%. So you can very well say that the sample which was taken in Ahmedabad was not representative sample. It was taken from relatively happier people like you people. So the we can say that sample was not represented. So standard error proportion, there are two uses of it. You find out the population proportion based on a sample proportion, or you find out whether the sample is representative or not from the population. Now I think once I cover this third one also, you should give me that kind of, or I will cover the 5 things and each one of you should be able to give at least one example, right? Now, when we say for standard error of difference, the standard error of mean, when we use the word standard of mean, there is one example written over here that the, let me take a white sheet to make it much better. There is a population of 50 lakh, let's say Surat, and then we want to take the mean duration of sleep taken by the Surtis. So mean duration of sleep equals to 8 hours plus minus standard deviation. Suppose it is in minutes, 480 minutes with standard deviation, uh, standard error. Standard deviation given, based on that we need to find out standard error of mean. So standard deviation is, let's say, 40 minutes. Now, based on this, you want to say that, and the sample size n is equal to, again, 500. Now, tell me what will be the mean durations of sleep of the Surat population based on 500. So, your formula you should use is standard error of mean is equal to, you should write down that square root of SD square upon n. SD square divided by n. So this will be standard error of mean. Again, I repeat, the standard of mean is nothing but one kind of standard deviation when we took a many samples around the mean of the samples. So the word is very complicated. Mean of the means of the sample. Mean of the means of the sample. If you draw on x-axis and y-axis number of samples, and at this juncture, the The standard deviation, when we are using it, that is labeled as standard of mean over here. So the roughly it would be square root of into bracket square of standard deviation 40 into 40 1600 divided by 500. So let us take it 400 for the sake of the um, unfortunately it is taking a formula, but I want to take like this. Um, Square root of let me take it here 40 400 to make it simple. Square root of square of this 1440 is a standard deviation. So 14 to 40 is equal to 600, right? Divided by n and take a root of this, right? So it will be the 4 and root will be 2. So standard error is equal to 2 minutes. Standard error is equal to 2 minutes. So for the Surti people, if you go for that, then the answer would be 480 plus minus 4. That will be the answer. So if you want to find out that what is the mean sleep duration of Surat people, 480 minutes plus minus 2 into 4 is 4. So 476 to 484, that will be the mean duration of sleep in Surat people. Now, instead of 50 lakh, if the population was 20 lakh, do you think the answer will be different? Say yes or no. Anyway, so if you think, if instead of 50 lakh, if we take 20 lakh population, will standard error differ? Question yes or no? No. Okay. Someone else? So when there is some difference in size, 20 lakh, 30 lakh, 50 lakh like this, there won't be any difference. Because when you take a sample, representative sample, suppose in your marriage party, you have, let's say, 100 liters of dudh pak or 100 liters of dudh pak, we say in Gujarati, and then you taste, and in your home, it is 1 liter of dudh pak. And then also you taste. Here you taste 1 chamach, means around 5 ml. Does it mean that you taste over here 500 ml? No, it's a sample. So if sample is representative, then standard error usually does not depend on the population size. So in this case, it will not differ much. But if population is only, let's say, 600, or if a population is 600 million, then there could be a difference, right? If it is too much different, otherwise, usually it will not get affected. So the one of the use of standard error of mean is to compare the population, to find out the population mean based on a sample mean. And other thing is, suppose municipal commissioner has found out that mean duration of sleep of Surti is 440 minutes. Then the answer is that in your sample it is the 480, while the population is 440. That means your sample is not representative of the Surat population. So I end my all the three types of Z over here. In terms of Z, suppose if say that Z is equal to population means 440, your sample mean is 480 divided by 2 is the standard of mean. Then you can say the Z is almost Z is equal to 40 divided by 2 is almost equal to 20. So it is far, far the bias sample taken by Surti people. So this is how these three kinds of Z we have learned today. All of you are supposed to either ask me the question or at least write down one example where you can either use Z for comparing individual with population, or you need to find out a Z for comparing sample with population in terms of proportion, or Z for comparing sample with population in terms of mean. These three things you should be able to prepare examples yourself right now. And I repeat that when you compare Z for comparing individual with the population, there is only one example. But when you want to compare sample with the population, you can find out the population proportion based on a sample proportion, or if population proportion is given, you can find out whether sample is representative of population or not. Same way for the mean. So let's have at least one example of any of the three. Prepare such example and write down in the chat box quickly. And I will not go for the rest of the 2Z. They compare between two proportion compared with two mean. That will take later on, but let us finish this. Let's see who is the quickest person to find out directly. While you prepare, let me prepare over here also. I will Z comparing individual with the population, right? I take the Mumbai population is, let's say, 1 CR. I want to find out CR and their mean duration of work is, let's say, 15 hours, and standard deviation is 0.5 hour. And I want to find out that how many percent of the people in the Bombay, they work between the 12 hours to 13 hours. Find out this. Or if it is difficult, then tell me, if a person is working for 17 hours, is it relatively compared to the Bombay population is beyond more than the usual population, or it is almost equal? If this is a question, two questions given to you. Anyone who can answer both the question? So how many people were working between 12 hours to 13 hours? Most of you may not be able to calculate, but that you calculate Z for both the thing. And that difference of Z, you find out the proportion of the people at that level of the Z. And then you minus it from 13 hours to 12 hours, and you can find out the exact population working between those hours. But then that may not be you may not be able to. But at least 17 hours. So 15 hours plus minus 0.5 hours, that is plus minus 1 hour. So usually people work between 14 hours to 16 hours. So person working for 70 hours is definitely more than that. We'll be taking mean in this case, yes, mean. But mean is already given over here. Mean duration is 15 hours. Here, sample is not given. Here's an individual is to compare with this. So we'll be using Z equals to population mean Population mean minus observation divided by SD. That we are going to use whether this is outlier or not. So in this case, Z is equal to population is 15 hour, and then this is a 17 hour in individual divided by standard deviation is 0.5. So 2 divided with 5 is equal to 4. Standard deviation Z is 4. So P probability that person belongs to Bombay Gra is less than 0.05. So we say that that person significantly workaholic, much more than what the Bombayites are doing it, right? So the next, someone of you should make at least one question before we end today's. Anyone? Make one question, write down over here. Another two Z's, what we are going to use, standard error of difference between two proportion, standard error of difference between two mean. That will be simple. Be comparing between two samples means population. Comparing between two samples means population. That is very simple. But this standard error of mean and standard of proportion, they were dual use. Anyone? Or give me the population, give me anything, and I make a this thing. Your the dissertation from that you should be able to do it. Mansa Faki, Dr. Mansa Faki, prepare at least one example. I don't know whether you have not understood or what is the problem. Rupashri, can you prepare one example? Rupashri, can you prepare one example? Or you just tell me only one parameter. Or only one. If we talk about the population, we use the word parameter. If we talk about the sample, we use the word variable. If you just say some variables, based on that, I can help you to prepare. Talk of any variable, right? So it could be a proportion. You should be able to proportion, or you should be able to find out mean. Just tell me one variable, and I can tell you that how we can prepare example. No participation. Okay, then let me switch over to the uh, various parameters where we'll be using what kind of the variables. Again, we go back to the our example of Oswego. Here, when you want to have comparison between two variables, both are where you can find out the proportion, chocolate versus the milk. Try to use the command tables, right? Use the command tables where you can find out proportion, for example, cakes versus illness. You use the command tables. But when you use the command here, automatically p value you will get it, right? P value you will get it over here. And when you have a standard difference between two mean, you want to calculate automatically with help of computer, not the manual one, then means of age and standard of difference between two mean that if you want to find out, you can say that rolls eater. Those who are taking rolls, their age was 39 years. Those not taking rolls, their age was 34 years. And this difference was statistically not significant. They applied a F test almost equal to standard of difference to mean. So, uh, again, somewhere else, if you want to use a mean of age versus those who like vanilla eaters? Is there any age difference? The old age people are like vanilla much more than the children, and but difference is just a bit and not statistically significant. Right? So, uh, region and diet, yes, region and diet. So, region and diet, somebody tried to give an example. So, I will say that there are two regions. Let's say one is south and north, and in diet, whether it's a vegetarian diet or non-vegetarian diet. If you want to compare this, right, south and north, then you are going to use standard of difference to proportion. But when you want to compare in a whole city, Mumbai, the proportion of vegetarian is, let's say, 67%. And one sample which sample you have taken, in that case, it was the proportion was uh, of vegetarian 45%, and the sample size n was the 200. Now, if someone says that whether the sample was representative or not, you are supposed to use standard error of proportion, right? That you should be using and telling whether the sample was representative or not. So, any other? It's good that at least one person has given a clue to prepare the example, right? Anyone else? So let me start the sharing. Again, um, any suggestions? So at the end of the day, you should be using the kappa test. You should be using the loss quality assessment sampling technique, and three types of Z you should be able to use. Compare individual with the population in terms of the mean, compare sample with the population, and in terms of proportions, compare sample with the population in terms of the mean, right? So I hope that you can at least share something in the group, if not over here. So the next section will be on the Thursday, and I hope that you will be coming with a few exercises or at least some of your dissertation. And I will be next time looking about two types of Z again, and then we'll be moving further with AP info. And if you have not learned the non-parametric test, we will be going through one of the non-parametric tests also in a small sample size. Thank you all.